Okay, 5.3 is thrown in here just to show you some properties of logs. Let's see, let me get it. Properties of logs. Okay, we're not solving any equations, we're just looking at these three rules right here, and we're working with that. Half of the problems are going to ask you to go from the smaller log and expand it into different logs, and then they're going to turn around and ask you to go backwards. Okay, so if you notice, the first one, if you have log of two things being multiplied, you can split it up into two separate logs. You would think that they would both be multiplying, but it's not. So if the two terms have been multiplied, when you split them into two individual logs, you add between the two. The second one, if you notice the two terms are being divided, then you subtract between the two. And then finally, this one is a great rule. When you have x to a power, you can bring that power down in front of the log. Okay? That's one of the properties of logarithms, and it's wonderful. All right, so like I said, all they're going to do is ask you just to use some of these rules. So for this one, they want you to expand it as far as you can. So this is what Pearson's going to be asking of you. So these two things are being multiplied, x to the 7th and y to the 6th. So if we want to split them up into two, we have log base 6 of x to the 7th plus, so you separate it, to the 6th of y to the 6th. Okay, you put a plus, addition sign between the two. Okay, that is expanded, but they want you to take it one step further. They want you, this is what Pearson wants for your final answer, they want you to use the third rule and bring those exponents down. So that would be 7 in front, log base 6 of x, plus 6 in front, log base 6 of y. This is what they're looking for when you type in your answer. Okay, this next one, use the product rule to expand the log expression, just like last time. Wherever possible, evaluate the logarithm expressions. Okay, so let's look at this. We have a log base 4 of 16 times x, so we can split that up in log base 4 of 16. And since it's being multiplied, we're going to add between the two, log base 4 of x. Okay, so from here, you really can't do much with the log base 4 of x, but when you look at the log base 4 of 16 at the beginning, if you can evaluate it, let's do so. And all we really can do is use the properties that are given to us. Right, so if you notice, 16 is 4 squared. And we know this property from the previous section that when you have the bases are the same, we know that this is 2, which is right here. Okay, that was one of those shortcut properties. So the log base 4 of 16 is the number 2. And that's what they're wanting you to do. And that's what they mean up here when they say evaluate the log wherever possible. That means convert log base 4 of 16 to 2. Okay, and for all we have and what we can do in this class, we don't have calculators to do that, so these are ones that you ought to be able to convert it this way into whole numbers. Okay, now looking at this next one, if you notice we have division, so I just wanted to show you this one. To split this up, let's see, we have a squared times b squared, so that would be natural log of a squared plus natural log of b squared. And the subtraction, the division means you subtract before that one. Okay, those are using the first two rules. And then one more step, let's bring our exponents down in front. And so my final answer would be natural log of 2 times natural log of a plus 2 natural log of b minus 6 natural log of c. And this is what they're looking for. Okay, once again, we're just showing that we know the rules. Okay, for this problem, I've noticed this in the homework. It might help you when we start because we're going to try to expand it. So you notice we have 1/9 times x, right, like that. So what I want to do before I even start, let's go ahead and multiply this together. 1/9 times x is the same as x over 9. This will just save you a little bit of time, make it a little bit easier for you. So now let's expand it. We have log base 3 of x. And because we're dividing the two terms, we're going to subtract between the logs. Okay? And one last step, we want to, wherever possible, evaluate logarithm expressions. And we can evaluate the log base 3 of 9. Right? 9 can be rewritten as 3 squared, and we know from our shortcut rule that when you have a log and the bases are the same, then this simplifies to 2. So we have log base 3 of x minus 2. This is my answer. All right, this one looks really large, so I wanted to work it. Before we get started, let's rewrite a few things. I am going to rewrite x, the square root is x to the 1/2. Right, and we've got, what, 10,000 y to the 5th. Okay, so when we're dividing these out, expanding these out, we want to start, of course, we have log of x to the 1/2. That's in the numerator, right? Now, if you notice in the denominator, we have two terms being multiplied. We have 10,000 and we have y to the 5th. So we do want to split these up, okay, and do them separately. So I'm going to subtract out, because it's being divided, log of 10,000, right? And then also, because y to the 5th is in the denominator, I'm also going to divide that out, which means I subtract that. This is kind of a shortcut, and if you look it up and Pearson shows you how to do it, they'll end up taking a few extra steps, which are completely the correct way to do it. But this is a little bit of a shorter way to approach the problem. So once again, what I like to think about is, if I have a term in the numerator, I'm going to add between the terms when I split them up into logs. But for every term that's in the denominator, it's like you're dividing each term out, which means you need to subtract each one. Okay, so I subtracted the log of 10,000 and I subtracted the log of y to the 5th. Okay, from there we can continue on with the problem, but that might help with getting it expanded. Okay, so from here, let's look. We can bring the 1/2 down in front. And there's not much else we can do with that. Notice the log of 10,000. Okay, if you wrote that as a 10 to a power, that would be 10 to the 4. Just a hint, the number of zeros is the exponent when you raise it to the 10th. When you raise 10 to a power, the number of zeros is the exponent. And we can bring the 5 down in front here. So the one last thing you could do is in the middle, log base 10. Remember, log, there's no base written, which means that's an understood 10. So once again, our shortcut method, when you have the same bases, that simplifies to just the number 4. So our final answer here would be this, okay, minus, that simplifies to 4, minus 5 log of y. This is my final answer. Okay, so now the second half of the homework, they're going to reverse it, and they want you to condense it into one log. So all they're doing is saying we just got to go backwards. So we have 2 log base 7s that are being added between the two. So going backwards, what we're going to do is we're going to start with taking the exponents and putting them back up, right? Going backwards. So that would be log base 7 of x squared. 7 of y to the 1/6 there. And now we have single logs right here, but they're being added. So to combine them into one, we're going back and using that first rule. When you combine them into one log, right, you multiply the terms. So that would be x squared times y to the 1/6. And that's all they're asking for right there. But remember, you are combining it into one log, so make sure you include the log base 7 in there. Okay, the second one, here we're going to do the same. We're going to combine them into one. We have all these log base 4s. So remember, this confuses some people because you have a subtraction at first and an addition. The way I like to think about it You, of course, could rearrange these if you wanted to. If you wanted to do the plus, if you wanted to switch these, you could. That might make more sense. But you don't have to do that. So I will undo that. But what you can do is, I like to think about it as I have log base 4. Okay. I have x squared. I have that. Okay. Minus means you're dividing, right? X squared minus 16. Okay, so the question here is, well, what do you do this? With plus, do you multiply on the bottom or on the top? Well, no, when you're adding, you're gonna multiply in the numerator, x plus 4. If I wanted the x plus 4 to be in the denominator, then when I subtracted, I would have had to group it together like that. But it's not grouped together. So I'm going to undo it. That's why some people like it. If you want to rearrange it from the beginning, it makes a little more sense to multiply the first and the last one first and then divide. But either way, this is what we have. And this is really kind of big, but they do want you to simplify. We're going to be able to factor and simplify. So let's look at that. And it does work out that way. Let's see. Okay. Let's see, on the bottom, that's what, x plus 4, x minus 4. On the top, let's do this. We've got, what, 6 times 4 is 24. Yeah. There we go. And if you notice, we can cross out. That works out nicely. So my final answer, simplified, is actually natural log of 4 of x minus 6. So it looks really big, but it does simplify. And I think you'll find the homework problems are similar, or anything you might see on a test is similar to this. Hey, once again, it's just a few problems from the section, but I hope that helps. It's only going over these properties. The next section, 5.4, is kind of the big section where we're actually solving equations.